Okay, good afternoon, everyone. Welcome to this my YouTube channel. My name is Barage Mbaradu, and this is Mass Mastering Academy. Please, if you are new here, kindly subscribe to the channel and let's study together. Thank you very much. I'm very happy that you are here today. Let's go into the topic that is before us today. Today, we are looking at how to solve differential equation, and this topic is very important. Pay attention to it. Thank you. Example 1. Solve the equation dy over dx equals to 6x squared minus 2x plus 5. Solution. Let's look at the solution. Given dy over dx equals to 6x squared minus 2x plus 5. Note that today we are looking at the equation of this form, dy over dx equals to f of x. That is what we are looking at today. And if we can be able to put our equation in this form, it will be very easy for us to integrate. And this particular one, this question number 1 is in this particular form. So let's look at how to solve it now. Given what they give us here, which is a dy over dx equals to 6x squared minus 2x plus 5. Now what we are going to do is that, as far as we know that the equation is in this particular form of dy over dx equals to function of x that is on our right hand side, that means all the terms that contain x is on our right hand side. So it's very easy for us to integrate. Now integrate both sides. So if you integrate both sides, we're going to have the integral of this function, which is this derivative, which is dy over dx equals to the integral of this function, which is 6x squared minus 2x plus 5 respect to x, and this function is also respect to x. We are integrating with respect to x. Now how are we going to do it? Now we know that this dx can cancel this dx here, and this integral sign will cancel this d here. So we're going to left with y equals to, now we integrate each of the terms in this function. So we're going to have, if you integrate 6x squared, you know that when you talk about integration, we're adding 1 to the power and divide it by the same power. So we're going to have here our constant, we bring it outside, and then you integrate this, which is x squared respect to x, minus, we bring our constant outside, we integrate our x here respect to x, then our constant here, we integrate our constant 5 with respect to the x. Now in this case, now what I'm going to do now next is that as we put this integration sign, we know that we have 6 here outside, times, if you integrate x squared, that means we are adding 1 to the power, which is 2. When you add 1 to 2, that is equal to 2 plus 1. Then you also bring out that 2 plus 1 in the downside. Then we come to the second one. We know that we have a constant 2 minus 2. Then when we integrate x here, we know that x have an invisible 1 according to the law of indices. So we're going to have the invisible 1 plus the 1 that we're adding, then also divided by 1 plus 1. Now when we integrate a constant, you know that this 5 did not have x attached to it. So we're going to have plus our constant, we just add x, because integration is the reverse of differentiation. In differentiation we minus, but integration we add. So we add it with respect of our derivative, which is x, then plus our constant c. Now what we're going to have here now is that we're going to have our y is equals to, you know that 2 plus 1 is 3. 3 going to 6, how many times? 2 times. So we're going to have 2, and 2 times our x going to go 2x. You know that on our x they have a power of 2 plus 1, which is going to give us 3, minus, here we know that 1 plus 1 is 2. 2 divided by this minus 2 is going to give us minus 1. Minus 1 times x is going to give us the same thing as x. And we know that this x have a power of 1 plus 1, which is equal to 2, then plus 5x plus c, and this is our final answer. And this final answer is called general solution. It is called general solution in a differentiation in a differential equation, because of the value of this c. We do not know the actual value of this c. Can be 2, can be 3, can be 5, can be 100. So because we do not know the value of this c, we call it general solution in differential equation. Let's look at another example. Our example 2 is giving us x times our first derivative, which is divided over the x, equals to 4x cubed plus 3. How are we going to solve this? Let's look at the solution. Now, we know that it's giving us x times dy over the x equals to 4x cubed plus 3. Note that here, our function is not in the form of dy over the x equals to f of x. So now we want everything concerning x to be on our right hand side, while our derivative will be on the left hand side. So because of that, we divide both sides by x. We divide both sides by x. Now if you divide both sides by x, we're going to have x times dy over the x all over x here. Then you come to the right hand side, we divide both sides also by x, and we have 4x cubed divided by x plus 3, we also divide by x. Now you know that this x cancel this x. We are going to be left with our dy over the x equals to, you know that this x go into this x cube, going to remain 2 s square. So we are going to have 4s square, then we have plus 3 all over x. Now it will be very easy for us to integrate. Now we integrate both sides. When we integrate the derivative of dy over the x equals to, we integrate each of these terms to integrate 4x square plus we integrate this, which is the integral of 3 all over x. Now you know that when we integrate this, what we are going to do now is that we are integrating with respect to x. So we integrate each of them with respect to x. We are going to have the y over the x with respect to x equals to the integral of 4x square with respect to x. That's why I put the that the s mean with respect to s. Then plus the integral of 3 all over x with respect to x. Now we know that this the x cancel the x here, and the integral sign cancel this d here. So we're going to left with y equals to, when we integrate 4s cubed, we bring our 4 outside, then we integrate x squared with respect to x plus, here the same thing we're going to do here. We bring our 3 here outside because it's constant, then we integrate 1 all over x, because if you say 1 times 3 times 1 is going to give us 3 all over x, right, with respect to x. Now we go on again, say y equals to, you see have our 4 outside here. If we integrate this, that means we are adding 1 to the power. We add 1 to the power here, so we're going to have times x. If I have 1 to the power of 2, become 3, you divide by the power 2, which is 3. I don't know if you understand. Then plus, you see have our const 3 here outside. If you integrate 1 all over s, that is become natural log of x, which is ln of x. Ln of x. Then plus our constant c. Now we know that our y equals to now become 4 times s cubed, become 4s cubed all over the 3 that was on the downside, plus you know that this is there's times here now that you already put it, that is 3 times ln x, 3 times ln of x plus our constant c, and this is the final answer. And this is called a general solution in differential equation, because the value of c, we do not know the actual value of c, so that's why I call it general solution. Now let's look at how to get a particular solution. Okay, example 3. Now let's look at how to find a particular solution. They say that we should solve the differential equation dy over the x equals to 4s cubed all over sine y, when x equals to 1 and y equals to 0. We should find the particular solution. How are we going to solve this solution? Let's look at how to solve it. You know that we are given the y over the x equals to 4s cubed all over sine y, right? Now, remember what I told us recently, that we need to put this equation in a form that we have the value of y one side and the value of x on the other side. So now let's make our everything concerning y to be on the left hand side. So we do cross multiplication. That means we are going to have this multiply this and this multiply this. So we're going to have, if you multiply this by this, we're going to have sine y times our dy, right, equals to, if we cross multiply, we're going to have 4s cubed times our dx, because we are cross multiplying. Now, after getting this, everything concerning y is on our left hand side and everything concerning x is on our right hand side. Now we integrate both sides. We're going to have the integral of sine y with respect to y equals to the integral of 4s cubed with respect to x. Now, if you integrate sine y with respect to y, we are going to have minus cos y. Then this is the integral of sine y, right? Now we look at the integral of 4s cubed. You know that this 4 here, we are adding the 4 here, we bring it outside, then we integrate. These are s cubed, which is s cubed with respect to the x. So we still have minus cos y, right, on our left hand side equals to, this 4 is constant, times, when you integrate this, we are adding 1 to the power. We're going to have x 1 plus 3 is 4, then also divide by that 4. Then okay, then we add plus c, which is our constant. Now after that, we know that we have minus cos y equals to 4 times this, give us 4s 4s to the power of 4 all over 4. So we know that 4 go to 4 divided by 7, which is 1. So we're going to have left with a 4s raised to the power of 4 plus c. Now here we bring this value to here, because this, we just bring it to this right hand side to make them be in the same form. So we're going to have x raised to the power of 4, when minus cos y plus the equality side become plus cos y plus our constant c equals to 0. Now at this point, they say that when x equals to 1 and y equals to 0, so we know that this x is equals to 1, so we are going to put 1 raised to the power of 4 plus our y is equal to 0. We have cos 0, right, plus our constant c equals to 0. Now 1 raised to the power of 4 is the same thing as 1 plus cos 0 is what? Cos 0 is 1 plus our constant c equals to 0. So we're going to have 2 plus c equals to 0. Our c become minus 2, because when this plus the 2 cross the equality side become minus 2. Now we know that our c is minus 2. For us to get the particular solution, we go back to this point, which is x raised to the power of 4, x raised to the power of 4 plus cos y. You know that our c now is minus 2, so we put minus 2, and this become our particular solution. This become our particular solution in the differential equation. Thank you very much. If you have any question, you can drop it on the comment section, and if you are not subscribed, please help us and subscribe. This is Maths Mastering Academy. Thank you very much. I'm happy that you are here.